Chapter 9, Chemical Methods of Control. The learning objectives for this topic are: compare and contrast 9 major types of antimicrobial chemicals and discuss the positive and negative aspects of each. Distinguish between phenol and the types of phenolics, and discuss their action as antimicrobial agents. Discuss the action of alcohols as antimicrobial agents, and explain why solutions of 70 to 80% alcohol are more effective than pure alcohols. Describe the use and action of oxidizing agents in microbial control. Define surfactants and discuss their antimicrobial action. Define heavy metals, give several examples, and describe their use in microbial control. Compare and contrast formaldehyde and glutaraldehyde as antimicrobial agents. Describe the advantages and disadvantages of gaseous agents of microbial control. Describe the use of an enzyme to remove most bacteria from food and to remove prions from medical instruments. Describe the types of antimicrobials and their use in environmental control of microorganisms. So the topic overview is, we're going to discuss phenols and phenolics, alcohols, halogens, oxidizing agents, surfactants, heavy metals, aldehydes, gaseous agents, enzymes, antimicrobials, and we'll end the topic with discussions about resistance.
Now on to the different active ingredients. Let's start with phenolics. Okay, I have a bottle of antibacterial hand soap because the active ingredient in that is a phenol. Here's the chemical formula of a phenol. Back at the beginning of learning to use disinfectants, Lister of Listerine fame would use carbolic acid or phenol as a surgical dressing, and also he would spray the wounds before and after surgery of the patients that he was working on, and they had a reduction of sepsis in the patient, of infection in the patient. Well, phenol in highly concentrated form, such as carbolic acid, causes cancer. So we don't use it in its highly concentrated form, and in fact we generally use it in a biphenol form because it's far less toxic. You could drink this stuff in most of its concentration that we use and it's not going to harm you, but it harms microbes. Okay? And because it was phenols and their derivatives were one of the first to be used as a surface disinfectant and as an antiseptic, that we still have a tendency to go back to that as the gold standard. Okay, so triclosan, you want to remember triclosan. Triclosan, if you look at your antibacterial soaps, you'll see triclosan listed. You'll see it listed on garbage can liners that advertise reducing smell. Well, if you decrease microbial growth, you decrease the smell. We put triclosan in all sorts of stuff, everything from baby diapers to cutting boards to shower curtains, you name it. Now the other phenol, or phenolic, that I want you to know is Hibiclens. Its active ingredient is chlorhexidine. It's a, and I'm not even going to make you learn how to say that, but you've got 2 phenol derivatives. We've replaced the OH group with a chlorine, and we've got this nice amine containing molecule that hooks it together. Now this means that it's active for longer. It takes the body and the environment longer to break it down, and you'll find chlorhexidine in a lot of antiseptic uses, kind of like triclosan. But with this one, Hibiclens is used as a antiseptic surgical scrub that various clinicians use before they don their gloves. And then also you will find chlorhexidine in oral mouth rinses that patients will use before oral surgery. The microbes in your mouth are your friends until there's going to be cutting to be done, and then you really don't want them in your bloodstream. So you want to decrease the numbers so that your immune system can handle them so that you don't have other infections. Now before we leave phenolics, let's talk about how they act to control microbial growth. They get in and they disrupt cell membranes. Okay, you can see how they would do it. This part is, you got it, hydrophobic. inserts into the cell membrane, you've got your other groups on there that act to pop those cell membranes. So I want you to remember the two examples of phenol or phenolics, and I want you to remember how it acts against cell membranes. On to the halogens. Now remember halogens from the infamous chapter 2. Halogens are the atoms that need just one more electron to have a full valence electron shell. So what do? They go around stealing electrons. Okay, and that wreaks havoc on microbes. Now, the most common halogen is chlorine. Now, bleach is sodium hypochlorite, and that's the one that you're most familiar with. Not only does it make your clothes whiter, but it kills microbes. We also use chlorine gas in treating city water and swimming pool water, such things. And what happens is that chlorine gets there and it impairs the activity of the enzymes. So basically it shuts down the enzymes function. Bromine, which is one down on the periodic table, it's a little bigger molecule, doesn't evaporate as fast. We have a tendency to use bromine for treating hot tub water. It's hotter, the chlorine would evaporate too fast, so we put bromine in, doesn't evaporate quite as fast. Iodine is also a halogen. It's one down from bromine. Now, because it's even bigger, its mode of action is a little bit different. It's still stealing electrons, but what it does is it forms complexes, at least so far as we know. It forms complexes with amino acids, and that inhibits protein synthesis. They also bind to unsaturated fats. Remember, an unsaturated fatty acid is one that doesn't have all of the bonds of a carbon taken up with a hydrogen, so it has some double bonds. So chlorine comes in, steals the electron from the double bond, breaks that double bond basically, straightens out the fatty acid, it's no longer the right shape. So halogens are highly effective in small quantities. Well, at least with bleaches, with your chlorines, there's a problem. And you probably already guessed it. If you're using that for a surface disinfectant, it's going to bleach everything. It's going to bleach your countertops, it's going to bleach your clothing, it's going to bleach your carpets if you spill it, and it doesn't smell very good. So we have a tendency to dilute it out, and we also have a tendency to use other surface disinfectants that aren't quite so caustic. Because, well, by caustic, one thing I forgot to mention, it also steals electrons from your metals. In other words, it corrodes your metals. So we have a tendency to use halogen sparingly or to bind it to other things that kind of reel in its electron stealing capabilities. On to the alcohols. Now you're familiar with isopropyl alcohol, rubbing alcohol, in its use as an antiseptic, as its use on human skin. Okay, it's highly effective. Not so good as a surface disinfectant. It's really quite good as an antiseptic, not so good as a surface disinfectant. If you take ethanol and use it in high quantities, such as in Lysol disinfectant spray, then that's much better as a surface disinfectant. Alcohols act by disrupting cell membranes. Okay? They also dehydrate cells. So those two things, pulling water out of cells, busting up the cell membrane, is how they kill. Now, one of the problems with alcohol is that it evaporates very quickly. Okay? So, with rubbing alcohol, that's not a problem. You're putting it on the skin to reduce the number of microbes, either after you've had a break in the skin or when you're going to put a break in the skin, like for hypodermic injection, etc. You do want it to evaporate quickly. When you're using a surface disinfectant, you don't want it to evaporate quickly. So part of the thing is that we put it in this aerosol can with these bottles of isopropyl. Every time you open it up, you get a little bit of alcohol evaporating, and so your concentration of alcohol to water goes down. So you might start out with 70%, but by the time you're done, you're more like 30%. So we put them in these pressurized canisters so that air doesn't get in as you force it out. And also, we put in other chemicals that help the alcohol to lay down so it doesn't beat up on your countertops. And we'll talk more about those surface active ingredients later on.
Well, I've gotten rather long-winded talking about stuff that I used to do for a living. Anyway, I'm going to stop here, and then we will pick up the rest of this topic in part 2.